So I'm gonna briefly introduce the product. So what is the mission of Vertex AI Search? It's basically to surface the relevant sources of information to satisfy the customer needs for information retrieval. So what does that mean? So relevant sources can mean anything. It can mean documents, it can mean images, it can mean snippets of text from documents, and so on and so forth. It can mean structured information, Jira tickets, you name it. And then the information retrieval part, you kind of need information when you do regular search, like internet search, when you do search on your public website, when you build a chatbot and you want it to be actually grounded so that it doesn't really tell stuff that's not necessarily true. And we want to do it for all customers. So all deployments, for all compliance requirements, and so on and so forth. And I think this is one revolution for search as well, is that within the Gen AI space, there's a massive application in terms of getting the information and corroborating that together with the LLM to get actual grounded answers that can be verified. And that's, I think, one of the traits that I'm looking the most in an LLM is to be factual rather than be chatty or funny. So I'm going to talk a bit about quality, which is kind of what I know how to do best. So what is really search quality? So it's really, really easy to explain. Given a query, what are the best documents to surface? And it's kind of like the google.com problem. You know, you're asking something and you want to get something back in return. So what does this mean? What do we need to do to achieve this goal? So we want to make sure that we have really good ranking, and we want to make sure that we have a very good retrieval. So retrieval is kind of like you go into a garden and you're looking for some fruit, and someone told you, I want to get the best 3 apples. And you're looking at a bunch of trees and you're like, oh, okay, that's an apple tree, that's an apple tree, and that's the retrieval. And then the ranking part is, okay, now that you've identified where you find the apples, let's pick the best out of them. And that's sort of the difference between these two things. And in terms of ranking, there's 2 main components. One is relevance. So is this really an apple? Was I really looking for an apple? And then there's the business objective, right? Which differs from company to company. Like some companies will want the apple that gives you the best ROI. Some other companies will want to give you the apple that makes you feel like you want to sit down more in their garden and spend more time in their garden. And for retrieval, there's 2 ways of doing it as well. One is the classical information retrieval theory, where you basically kind of have, let's say, a map of the garden, and you look at it and you're like, I kind of know that apples are there and there. And then there's the dense retrieval, which is basically based on embeddings, and you kind of just glance a bit at it and you go like, oh, it might be here, here, and here. And that's sort of the type of work that we're doing. And I'm giving you high level. It doesn't work that easy, and the devil's always in the details, but that's the general gist of it. In terms of the use cases that we cover, there's quite an extensive list of use cases. So we're covering structured documents like retail, media. That's a big thing overall. We cover unstructured documents. So these would mean essentially all documents can be seen as unstructured. Even if they're structured, you can still see them as unstructured. But the difference between these two is that the structured documents have some type of information that might help you even more when you do the ranking rather than the unstructured documents. And then you want to do blended search. So that means like, okay, find me the bugs that are assigned to me in the last 10 days that talk about this project, right? And that means like figuring out what that project was about, getting the documents that correspond to that project, and figuring out what bugs are linked to it. And it's a fairly involved thing, but if you think about it, like in today's age, a lot of revenue from companies is spent on their employees. So creating tools that facilitates their employees to work better and faster is, I think, really, really important, and it will drive a lot of improvement in their businesses and really make the difference in the market. And then there's experiences, right? So there's regular keyword search. You go to Reddit, Dailymotion, and you search for like, I don't know, F1 Qatar or whatever, right? Like that's a keyword-based search. You kind of just want to get the results that match it, and the ones that are like, I don't know, most popular, let's say, right? And then there's natural language questions, like the one I just mentioned with the Baganizer ticket or the Jira tickets. And then there's the dialoguing conversation, which is, again, like a super interesting area that yeah, Nicolo and the team and Viola are working on. But they also use search essentially, right? And it's a lot more about having a continuous way to interact with the um, search results within your corpus, and not only, right? You can also want to have search results that blend internal and external knowledge, and so on and so forth. So that being said, I just wanted to talk briefly about how we achieve these things. So one of the really cool things about coming to Vertex AI Search is that we're built on top of Google Search foundational technologies. So a lot of the stuff that's in Google Search, you'll find in Vertex AI Search. And then we need to also do some other extra stuff, right? To tailor it to our customers. So we want to leverage extra cloud signals, right? Like echo embeddings, they are one of our signals that we can do. Then you want to do search tuning, right? When you're on google.com, we control the ranking. So we can have our objectives that align with our business goals and so on. But that's not necessarily true for all customers. They might have different business goals. So we need to give them the flexibility to tune their search systems, right? And we also don't want to overwhelm them, right? Like if you look at Elastic, there's an overwhelming number of knobs that you can do. But essentially, all of the motivations for using search, they're business driven. So if we can provide an efficient way of mapping that business objective into the ranking, that would be ideal. And then we use Gemini derived ranking signals. So this is one of the coolest things is we are fine tuning, for instance, Gemini Ultra to predict relevance, right? And you can do that at Google, right? It's a process intensive fine tuning, but you can do it. You're going to get really good results. And then that model behaves better than an average human rater. And that unlocks so many applications, right? And we've been doing a lot of work on essentially taking these LLM signals, getting really, really the best quality of results for our labels, sort of, and then distilling it into very, 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 very tiny models. And finally, it's very useful for RAG applications. And there's two things I wanted to highlight. One is extractive segments. So that's kind of like the snippets that you get on google.com. Like you search for, I don't know, how tall is Roger Federer, and you get like a small bit of answer, right? That's very useful in a corporate setting. Most of the questions will be along those lines. So if you can do it and then you find out where the correct snippet is and then feed it into the LLM, it will do a much better job at giving you the correct answer. And then, yeah, chunked documents is another big one. And that's because, right, there's a lot of problems with handling tables and handling huge documents. Like we have customers that give us 1,000 pages of PDF. It's really hard to, at serving time, to not only rank it, but also figure out where the correct text is. It's genuinely a challenging problem. So you can do a bunch of like hedging strategies, like chunking it, making sure that you understand the doc very well, and putting it into smaller, sort of semantically relevant things into the corpus, and then you can really surface great results. And that'll be it. To that, I'll leave it to Neda.